We are designing our own functions, okay? So these are called recipes, designing your own contracts, design recipe. There's a couple important steps that we'll have to pay attention to. So here's the first one. We have to state the contract and the purpose. So that's already in your code for the most part. That's this first line over here. Okay, define some builder functions, line 33 in my code, and I'll make it bigger. Okay, is fixed, : r, row, boolean. And then we can add in the second thing. Consumes, right, the input or the domain is an animal, and looks up the value in the fixed column. That's the job of isFixed. Notice it's a little different than before. R in this case represents, is a variable. It's a temporary thing. We could just replace it with animal, and then what we do is replace it with animal down here and here, and it makes works just the same. So these hashtags, that's how we tell the computer to ignore these lines of code. This contract just states how to use this function, right? Think back to here, when we go to like 66, it's like these. You're telling them the domain and what to expect for their range. Now the next part is writing down some examples. You're telling the user how to use your function. So then here, right, block 8, we fixed it to being true. But in this case, it could be false, right? The animal A and animal B are animals that don't really exist just yet. It's not the same as these over here. So this is how you would use the function. It could be true and it could be false. Notice these bolded words. Having examples is needed when you're defining new functions. Otherwise, when you mess up, you're going to be unsure of how to fix it. Okay. And the last part is coming up with actual values. So here, fun right here, and we can make this on the new line. Fun stands for function. Is fixed. You take in an animal, and then you check that specific animal's fixed column, and then you're done. Okay, so then if we click run, all this should work. Yep, one test failed. Oh darn. So that's probably the second one, right? Because animal A and animal B, right side was false. Make sure the booleans are correct for your animal. Oops, no, you're right. Tracy's absolutely right. You can even add in a is fixed here for animal C, and let's see what it's supposed to be. So we're checking our work. Animal C. Daisy is also fixed, like that. Okay. Good. And they both pass. Great. Now we go check here, and our goal is to run an animal function, or a gender function, type gender into the interactions area. So the word problem at the bottom of page 10 is just walking us through. Here's a template that helps us create the gender function, okay, which consumes a row of the animals table and looks up the gender of that animal. Sweet. So it sounds just like here with the isFixed function, but now we'll just change some words. So because I noticed those similarities, I'm going to copy and paste this and change the part that needs changing. We still take in an animal, which is of type role, and then over here it's going to return not a boolean, but the string. It's either going to be male or female. Consumes the animals and looks up the gender. So the string in the gender column. So then for our specific examples, let's check animal A. Animal A, gender is female, so it's no longer true. We gotta replace it with the word female. Animal B, no, animal C, okay, is also female. Then animal B Fritz is male. Okay. So for our specific test, these are the values. If you chose different animals, you have to change your examples here. And now down here, we're no longer is fixed. We're changing that name. This is now our gender function. Anytime we see that, we will replace it. Gender, 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 gender. It takes in an animal, and we look up not whether or not the animal is fixed. We look up that animal's gender. And now we can click run. Let's see, we should pass all our tests. We made this thing, okay, this is the new stuff, great. Let's see if it works. Gender, animal A. Great, animal A is female. Let's see, gender, animal D, female. Is animal D a female? Nori, the dog, is in fact a female. Great. So our function works as we typed it. So far, our functions have all been lookup functions. They consume a row and they look up one column from that row as is. And as long as that row contains Boolean values, Booleans are true and false, we can use that function with the filter method. But what if we want to filter by a Boolean expression? For example, what if we want to find out specifically whether or not an animal is a cat or whether it's young? And then we look at page 11. Now looking up, is it a cat? Is it young? So the isCat function has to do some computing. We have to do some comparisons. We have to look up certain things. What's the name of the function? It's going to be isCat. What's the domain? We look at here. It tells us it intakes a row of information, and then the range, it's going to return a Boolean. That's the output. Is Sasha a cat? What did you do to get that answer? Well, gotta find where Sasha is. So animals dash table. Find Sasha. Sasha the cat. Yep. Sasha is in fact a cat. And what did you do to get that answer? Well, I have to find Sasha's row and then look under the species column to see whether or not it was cat. Okay, those are the mechanical procedures. That's what I did. So, just like before, we can save some time, copy and paste, replace the parts that do remain changed, like here. It's no longer the gender function, it's the isCat function. We take in an animal, and it returns a string. And that's going to be cat or dog. Consumes an animal and looks up the string in the species column. That's not quite it. Not only do we look it up, we compare to see if the string in the species column is cat or not. Right? That's different than before. We're doing a little bit more. Is dash cat, is dash cat, is dash cat. Let's double check. Animal A, are you a cat? Mittens is in fact a cat. So we should see not the word male and female anymore, but cat. And then animal B. Okay, so then we do some comparisons. Is cat equals cat. And this one, Fritz, since Fritz is a dog, that's animal B. Notice we're going to replace this part down here, dog. That's going to be equal to cat. That in itself, this expression that I'm highlighting right now, that's what gives you your false value. These values don't match. That's why this test is going to be false. And at that point, we're good. We don't need this part. Let's move on to the next slide. Now they give us a little hint. How do we define our function? Is cat takes in an animal, row, right, a row, and then you check the animal's species, and now you have to do some comparisons. Species, does that equal, that's two equal signs, equal cat. So it looks like this. Now when we click run, we should see that our test should pass. Cat, yep, down here. Cat does equal cat, dog does not equal cat. That's what we expected, okay? So we did this, Click run, and here's the new part. Let's just check. Let's just see that it works. Is animal C a cat? Animal. Oh, I capitalized it, my bad. Animal C a cat. False. We can check. Animal C, are you in fact a cat? Daisy is a dog. Okay. Animal is cat contained in animal D. Oops. 2 parentheses. Animal D. False. Let's see. Animal D is what I'm typing in as I press enter. Nori is a dog. So looks like this function works. Now, because they return true and false, we can use this to filter our table. Let's see. This will only get us cats though. So animals-table dot filter is cat. Now we're able to extract, we're able to filter out whether or not all the cats from the animal table. It looks like we only have 11 of them. Cat, 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 cat. All these are the cats. Sweet. So you can easily change this to modify it to be dogs, get all dogs from the table, or get all whatever you're interested in. And then, for more practice, let's walk through this pattern yet again for is young. So we look at page 11 down here, is young, and here's the part. Oh, you know what I forgot to do? I forgot to change. Nope, we did. So down here, consumes a row for the animals table and computes whether or not it's less than 4 years old. So I'm going to borrow this stuff, copy and paste it onto here. It's kind of messed up. And then I'll put a comment here. Consumes a row, animal row, animal row. Alright, so we got the first part. You can borrow some stuff. Is young, colon, colon, takes in an animal that represents your row, and then it's going to give you a boolean, true or false. I guess that's the part I need to change here. So from the previous function, it didn't give me a string, give me a boolean, true or false. And then, just like before, down here we give some examples. So is young, oops, animal A. Let's see, animal A. Animal A, age. Yep, so animal age is true. Well, so here's the part, is 2 less than 4. Is dash young, animal B, we should expect animal B, animal B to be, oh, it's going to be false. 4 is not less than 4. So animal B doesn't count as young, but animal A does. That is to say, Fritz, this dog, is too old. It's more than 4 years, but this animal, Mittens, is young. He's only 2 years old. Okay, forget your end. And now we define that actual function. So is dash young is my function. I take in an animal row, colon, animal, square bracket. We look up its age column. Okay, age. Then we do the comparison. It has to be less than 4. And now we can test, run our code. And now we can see is young animal, lowercase, animal A, true. What about is the animal B young, false. Let's see if Animal C is young. Animal C. Oops. C. False. Let's see if that's actually true. Animal C. Let's use a lookup instead of scrolling. Age. Yep, 5 is not less than that, so that's why we returned false. Now one final check is young. Animal D. Animal D's, we want the age. Let's take a peek at that number. Yep, 3 isn't less than that. Let's see this next part. So it's asking us, like, filter, this method, a very powerful method, only works for things that are true and false. Gender returns male and female. It doesn't give you true and false. Let's see what happens when we try to filter the table by gender. Animals-table dot filter. Now here's the name, gender. Expected true or false for the test Boolean expression built in, blah blah blah, female. Oh darn, that's our error. So we have to add in a new thing that motivates this next part. We're adding a new column to our animals table, and that's going to be called is young. That's when it has this is young, or right, it could be gender. Sorry, I misread this. Notice the domain.filter says the test must be a function. That's the arrow, which consumes a row and produces Boolean. If the function we pass produces anything else, we'll get an error. So we can filter by male and female. We have to just achieve that another way. Perhaps we can sort it by gender, male and female, and then just ignore the ones that are not male or ignore the ones that are not female. The last thing we'll learn for Unit 2 is adding columns into our thing. We'll just copy this part and paste it in. So everything that is now, let's look it up, right? We use build column. So if we look up here, 66, we check here, build column. Takes in a string, and then the builder, right? That's the functions we made, like gender, like is young. No. Yeah, like gender is young. Gender is young. Yeah, so build is fixed, is young, gender, those things count as builders, right? They take in a row and they give you a different value. Now to our table, if we go back to here, we see that at the very end, after what used to be weeks, we have now this true-false value of whether or not it's less than 4 months old, right? It's age. That's the new stuff. In case we need to add in new data to work with, like after doing some question asking and massaging, we need to add new stuff. That's that function. So that's Unit 2. We explored the animal data set. We made our own questions, kinda. We followed the ones the book gave us. And then we thought about how do we make Pirate answer those questions, or using Pirate as a tool to help answer those questions. Mostly they're like yes, no, and comparisons. This is a big skill that we'll work on to going into the next unit, and to find some interesting patterns in whatever data set we choose to analyze.